Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our subject Basic Electrical Engineering in chapter AC circuits we'll understand generation of AC voltage and discuss the working of sinusoidal alternating current generator or alternator where relative motion between working magnetic field and armature conductor results in time varying magnetic flux linkages and dynamically induced EMF in conductors. And the most significant thing is when instantaneous flux linkages in a coil is zero, at that instant it would have maximum induced EMF. So let's understand generation of AC voltage. The generation of standard power frequency sinusoidal alternating current AC supply is a critical aspect of our electrical power system. The typical standard power frequency is either 50 Hz in majority of world including India and is 60 Hz in USA and some Arab countries, and this 50 or 60 Hz power frequency alternating current supply is used for generation, transmission at higher voltages to large distances in bulk amount, and then the distribution of same electric supply takes place and electricity at convenient reduced voltage is used by various consumers. So entire generation, transmission, distribution and utilization of electrical energy worldwide is in the form of alternating current, and in this learning video we will discuss the basic principle of generation of power frequency sinusoidal alternating current. Sinusoidal power supply waveforms are periodic waveforms. They repeat themselves in a cyclic manner, and alternating current supply are represented by sine or cosine function of trigonometry. And in a typical sinusoidal alternating supply, the magnitude increases at a higher rate from zero initially, and rate of increase continuously decreases and magnitude attain positive peak, and after positive peak it decreases initially with smaller rate and then at faster rate again attain zero level, and voltage change its polarity and current change its direction, and same variation changing polarity or direction after every half cycle is repeated again and again. When a conductor or a coil is moved or rotated with respect to a magnetic field such that conductor cuts magnetic lines of force or the coil have time varying flux linkages, then as per Michael Faraday law of electromagnetic induction, coil will have dynamically induced EMF or electromotive force. A simple schematic generator consists of a pair of permanent magnet or electromagnet which produce a strong uniform fixed magnetic field between north pole and south pole where conductor moves, and when a rectangle current loop is rotated by a mechanical prime mover around its fixed horizontal axis, the rotation of coil configuration produce time varying flux linkages when the conductor cuts magnetic lines of force at various angular positions. Rectangle coil loop rotates in anti-clockwise direction around its center horizontal axis, and strong working magnetic field is perpendicular to this horizontal axis as shown here. Initially, this rectangle loop in vertical plane got its surface area perpendicular to working magnetic field as illustrated here. This black diagram is area of rectangle loop and this red arrow is a direction of magnetic field, and flux linking to this rectangle loop at this moment given as dot product of magnetic induction vector and area vector, and the direction of area vector is always normal to the plane outward as shown here by n cap, and in this initial condition B vector and area vector got an angle 0 degree, and this rectangle loop have maximum flux linkages, and as this rectangle loop rotates in anti-clockwise direction with a uniform angular velocity, the angular position of rectangle loop and magnetic induction changes with time, and at different angular positions as the loop rotate there will be time varying flux linkages with rectangle loop, and the amount of induced EMF EMF in this rectangular loop at any instant is proportional to rate of change of flux linkages with respect to time, as per Faraday's law of electromagnetic induction. Initially, when rotating coil plane is in vertical position, the magnetic induction vector and area vector get aligned, and this rectangle loop will have maximum flux linkages, and anti-clockwise rotation of rectangle loop co-sinusoidally decrease magnetic flux linkages with respect to time, as shown by this blue diagram. But induced EMF is not produced only by flux linkages, but it is produced by time rate of change of flux linkages, and at A position, instantaneous flux linkages with rectangle loop is maximum, but rate of change of that flux linkages is 0. So induced EMF in this coil configuration at this time instant when coil is vertical having maximum flux linkages is 0. But as rotation of rectangle loop involve time variation of flux linkages, there will be induced EMF as shown by red colored wave. Initially, when rectangle loop is vertical and perpendicular to fixed magnetic field induction, the flux linking with rectangle loop as per dot product of magnetic induction and area vector given as cosine function of angle between B vector and area vector theta, which is at t equal to 0 is 0 and cos 0 is 1. So this rectangle loop at initial A position got maximum flux linkages, and as it rotate in anti-clockwise direction with constant angular velocity, the area vector with time produce omega t angle, and this dot product of B magnetic induction vector and A area vector with cosine of angle between the two omega t become a cosine function of time as BA cos omega t, and as shown in this blue wave diagram, as per cosine of angle between B vector and area vector due to this rotation of rectangle loop, magnetic flux linking to the loop decreases as per cosine relation, and in C position when rotating rectangle loop become horizontal in position and its plane get parallel to magnetic induction, and area vector and B vector got a 90-degree angle, cos 90 is 0. So no flux will cross or link with area loop, and at this C position flux linking to rectangle loop become 0. Now in this cosinusoidal variation of flux, initially flux is decreasing at a smaller rate, and later on near C position rate of change of flux linkages with respect to time increases in magnitude, and accordingly as per Faraday's law of electromagnetic induction, induced EMF, which is directly proportional to rate of change of flux linkages, which is initially at A position with maximum flux linkages as shown in red curve, is 0, and as flux decreases induced EMF increases, and in C position when flux linking to the rectangle loop is 0 but the rate of change is maximum, so induced EMF in this C position is maximum. Anti-clockwise direction rotation of rectangle loop from position A to position C results as reduction in flux linkages as cosine of angle between B vector and area vector, and as per rate of change of this cosine function, induced EMF become a sine function of angle between B vector and area vector, and as time progresses from A position to C position, as omega t increases as shown in this red wave, induced EMF increases and become maximum at position C when coil plane is get aligned with magnetic field force lines, and the further anti-clockwise rotation of the same loop once again increase flux linkages with a rectangle loop, but now it is in opposite direction, and from C to position E when again rectangle loop become perpendicular to magnetic force lines, the flux linkages become maximum but in opposite direction, and as per rate of change of flux linkages, this cos omega t when differentiated become minus omega sin omega t, and with this negative side differentiation negative become positive, and induced EMF will become NBA omega sin omega t. It's a sinusoidal function with peak magnitude NBA omega, and this induced EMF, which become maximum at position C, decreases in magnitude from C to D and up to E as shown here in this yellow highlighted portion. So from C to E angular motion, flux linkages increases and rate of change of flux linkages decreases, and at E position flux linkages once again become maximum but induced EMF becomes zero. As the rectangular loop rotates in anti-clockwise direction from position A to position E, flux linking to it, which was initially at positive peak, continuously decreases, becomes zero at position C, change its polarity after C, and attain maximum peak value in opposite direction at position E. So from A to E, it continuously decreases at different rate of change with respect to time, and accordingly as per rate of change of flux linkages, induced EMF, negation of d phi by dt. d phi by dt from A to E is negative, and negation of that induced EMF is positive from A to E. And at C position, when instantaneously flux linkages is zero, rate of change of flux linkages was maximum and induced EMF at position C is maximum. So there is a half cycle of EMF and further rotation of same rectangle loop in anti-clockwise direction. Continuously increase flux linkages. First it reduce in opposite direction, become zero at position G, and then increase in initial previous direction and attain positive peak as it was in initial position, and the similar half cycle pattern of induced EMF as per rate of change of flux linkages. Flux linkages is continuously increasing, have positive change, and negation of that results in negative value of induced EMF. And at E and A, when flux linkages are respectively negative peak and positive peak, rate of change of flux linkages being zero, induced EMF at position E when rectangle loop perpendicular to force lines got maximum flux linkages, and at position A again rectangle loop perpendicular to force lines having maximum flux linkages got minimum rate of change of flux linkages and zero induced EMF. And at G position, when flux linkages was zero, rate of change of flux linkages being maximum got maximum induced EMF. So in first half rotation, induced EMF got a positive half cycle, and in next half rotation, induced EMF got a negative half cycle. So we can see that when this rectangle loop or coil physically rotates and produce one complete revolution between this one pair of pole or two number of poles, one full cosinusoidal flux variation cycle will take place, and corresponding to that as per rate of change of flux linkages, a one full sinusoidal waveform of induced EMF is produced. So one rotation of rectangle loop produce one complete cycle of induced EMF, and connection of rectangle coil are made to external load circuit through slip rings and brushes, and we can utilize induced sinusoidal EMF in external load via slip ring and brush arrangement in this generator. As this rectangle coil loop rotates in anti-clockwise direction with constant angular velocity as per angle between magnetic induction vector and area vector as a linear function of time omega t. The cosine of that angle results in time varying flux linkages with rectangle loop, and as per negation of rate of change of flux linkages, E is equal to minus n d phi by dt, and when flux is written as Ba cos omega t, the differentiation of cos omega t is minus omega sine omega t. Negative with this negative sign become positive, and induced EMF got peak value nba omega, and it become a sinusoidal time function as this rectangle loop rotate here in this constant magnetic field. The RMS value of induced EMF is 1 by root 2 times of peak value, and it is given by this relation, and we can say the magnitude of induced EMF in this rotating coil is determined by following three factors. Induced EMF is directly proportional to the speed at which this rectangle loop is rotating. Higher the speed of rotation, higher would be the rate of change of flux linkages, and higher would be the induced EMF. So induced EMF is directly proportional to angular velocity of rotation. It depends upon the strength of working magnetic field around this rotating loop. Higher the strength of magnetic field, higher would be the flux linkages with the given area of rectangle loop, and higher would be the rate of change of flux linkages. So induced EMF is directly proportional to the strength of magnetic induction. It is also directly proportional to the number of turns in the rectangle loop. Higher the number of turns, higher would be the EMF, and this EMF also depends depends upon the area of rectangle loop. Higher area would have higher amount of flux linkages and higher rate of change of flux linkages or higher amount of EMF. So induced EMF is directly proportional to number of turns, strength of working magnetic field, area of loop or rotating velocity of loop. In standard sinusoidal wave, one cycle is a set of non-repetitive values that repeat themselves again and again, and number of times such cycles appears in 1 second time duration is known as frequency of sinusoidal supply, and this frequency or cycle per second is measured in hertz. The frequency of sinusoidal supply depends on how quickly the generator is rotating. In our example, when this rectangle coil rotates and make one complete rotation, one cyclic variation of induced EMF will be produced. So frequency of induced EMF is directly proportional to speed of rotation or revolution per second of rotating rectangle coil. Frequency is directly proportional to revolution per second of rotating structure. In this two-pole alternator having one pair of poles, one rotation of rectangle loop produce one cycle of alternating induced EMF supply. If we add more number of magnetic pole in these generator, then for each revolution of this rectangle loop, proportionally more number of cycles will be produced for the same rotational speed. Therefore, we can say frequency not only proportional to rotating speed, it is also proportional to number of pole. So frequency of alternator is directly proportional to product of revolution per second and number of poles. And for this one pair of pole or two number of poles, if pole number is 2, one cycle of rotation produce one cycle of sinusoidal induced EMF, and n revolution per second will produce n number of cycles in second. So frequency is n for p equal to 2, and for 4 number of poles, frequency is 2 times revolution per second, and higher the number of poles, higher would be the frequency. Generation of power frequency sinusoidal alternating current is the backbone of modern electric power system. Almost 95% of total electrical energy generated, transmitted, distributed or utilized is alternating current in nature, and power plant such as coal thermal plant, hydroelectric plants, nuclear power plants or renewable energy based plant, whether it is wind energy or solar photovoltaic, all ultimately generate sinusoidal alternating current for transmission and distribution. In these generator, the prime mover, whether it is steam turbine in nuclear and coal thermal plant or hydel turbine in hydroelectric plant or wind turbine, all convert their mechanical energy into rotational motion, and attached synchronous generator or double fed induction generator or grid connected converter produce sinusoidal electric supply of standard 50 Hz or 60 Hz. For economic of design and ease of operation in real practical alternator, the rotating structure is working magnetic field and stationary part is high power, high voltage and high current armature coil configuration. Rotating magnetic field is created by DC supply excitation, and mechanical prime mover when rotate this magnetic field structure, flux linking to stationary armature coils changes with respect to time, and in this three-phase space displaced short pitch distributed winding, three-phase time displaced excitation is produced. Stator winding have many coils of several turns of wire of sufficient cross section, and that produce required amount of power as per designed voltage and designed current. The basic working principle of this practical alternator with stationary conductor and rotating magnetic field is the same as we have illustrated fixed magnetic field and rotating conductor configuration. Rotating generators have limitation of maximum voltage that they can produce, and for economic and efficient power transmission, generated AC voltage is stepped up near generating station using static transformers, and electric power is transmitted at long distance in bulk power amount at very high voltage 765 kilovolt or 400 kilovolt or 220 kilovolt in primary transmission system and 132 kilovolt in secondary transmission system, and later on this transmitted power is distributed among different sections at reduced 33 kV, 11 kV or 415 volt 3 phase or 230 volt single phase to different type of consumers. And this functioning of transformer step up near generating plant and step down near consumer reduce cost of transmission and distribution system, increase its efficiency and performance. In these transformer which are situated at substations, we have facility to regulate voltage level to ensure standard rated regulated voltage supply to different consumers. Step down distribution transformer mounted on pole near consumer premises reduce voltage level to safe working voltage level, and we supply electrical power to residential, commercial and industrial consumers. Now this power frequency alternating current power is used in wide range of devices and application including lighting, heating, ventilation, motor, appliances and several type of industrial and other machineries. We hope this beautiful learning video has explained the generation of alternating current voltage, and it has also explained the working of AC generator and how flux variation result in induced EMF of standard sinusoidal alternating nature. Our other learning video of the same playlist are equally useful in clarity of subject and exam preparation. If you need dedicated exam centric notes from our channel or need online doubt clearing classes, do join our YouTube membership. Happy learning. Have nice time. Thank you very much.